Okay. So now let us start. All right. So we're going to look at questions 5 today. Now, questions 5, if you've tried these questions, I'm not sure whether you observe the diagrams or not. You look at the diagram carefully or not. Now, let's look at this diagram. This diagram, you are given three vector, which is vector f1, vector f2, vector f3. F1 and F3 is fine. Why? Because both of them, they are pointing outwards, coming out from the origin. But if you look at force number 2, F2, the arrow is pointing towards the object, towards the center, towards the origin. Now, in this case, you cannot straight away resolve the vector. What are you going to do? You need to extrapolate it. You need to let it come out from the other side. Okay, you need to let it come out from the other side. And this would be the vector that you're going to use in your calculations. Then how about the original vector? Now you don't want it anymore. Okay, so you can remove it. So angle 45 degrees here. Okay. So what are you going to do now? You extrapolate it, let it come out from the other side, and then you remove the original one. So the new vector will look like this. Okay, the new xy plane. So this is what is going to happen. So this is f1, and then this is a y-axis, x-axis. So f1, 20 degree, and then f2 here, 45 degree beside x-axis, and then f3, and it's a 30 degree, okay, beside x-axis. So this is the final diagram that you're going to resolve. So whenever you have a vector that is pointing towards the center, then you let it come out, okay, you move it to opposite quadrant. So you let it come out from the other side, because all vectors can only coming out from an object, from an origin, but it cannot be enters into an origin. Okay, it cannot enters into an object. So let it come out from the other side, and then you remove the original one. So now your F2, 30 Newton, is in the fourth quadrant. So it is very important, because if you have the vector in the wrong quadrant, then you are going to have a wrong sign in your calculations. So you have X and Y now. So F1, F2, F3. So what are you going to do next? You are just going to resolve it. Okay, you're going to resolve it. So now I give you 2 minutes to complete this table. See whether you still remember how to resolve the vector or not. All right, so I give you 2 minutes. This is your 10 Newton. This is 30 Newton. And then this is 40 Newton. Okay, so you resolve it. I give you 2 minutes. See if you can answer it. Remember to include the sign, okay? When to use positive, when to use negative. All right, now let us look at the table. Okay, let us complete the table right now. So F1 is 10 Newton, if you look at the diagram, and then the angle is beside X component, 20 degrees beside X. Therefore, for X component, we are going to use 10 cos 20 degree. Okay, so cos for X component because angle is located beside beside X component, sorry. And for Y component, then you just use sine. So 10 sine 20 degree. Whereas for F2, now F2 is in the fourth quadrant. Okay, so fourth quadrant, X component is still a positive value. Angle is beside X component, so 30 cos 45 degree. Now Y component, because now if you resolve F2, then F2 would be pointing downwards. Okay, going to the right and down if you resolve it. Therefore, for the Y component, it is a negative value. So negative 30 sine 45 degree. Whereas for F3, which is located in the third component and third quadrant, so if you resolve it, it's going to the left and also going downwards. So in which it means both X and Y components are going to be a negative vector. So negative 40 cos 30 degree, negative 40 sine 30 degree. Now, what are you going to do next? Now, since the question asks you to calculate resultant, means the total, then you're just going to add them up. So you add them up, you're going to get a negative 4 Newton along the X component. So I'm going to call it Fx to represent it is a resultant force along X component, okay, along X axis. So it is a negative 4 Newton, whereas for the Y component, Fy, I got a, I think, 37.8 Newton. Okay, so negative 37, sorry. So negative 37.8 Newton for the resultants along Y component. So now that I have the resultant for X components and also for Y component, I can then draw the positions of a resultant vector. So this is my XY plane as usual. So this is X component, this is Y component. And then according to my table, it tells me that Fx is equals to negative 4. Negative means that the force vector is pointing to the left. Okay, so in vector, if you have a negative along horizontal component, means it's going to the left. If you have positive, means it's going to the right. So now I have going to the left, okay, because it is negative. So this is my Fx. And then if you look at Y component, now Y component, if you got a positive value, mean it's going up. If negative, mean it's going down. So I have a negative value here, so it's going down. So this is my Fy. So when I combine two of them together, when I merge these two vectors together, they are going to give me a resultant vector in the third quadrant, where the angle is beside X component, if you use tangent theta. So resultant, I'm just going to call it F without subscript. So subscript is very important. Okay, subscript is very important when it comes to vector, so that you know where whether the force vector is located on the X component or Y component, or whether it is a resultant or it belongs to a separate object. Okay, each individual force. So once you have this vector diagram, then you can calculate the resultant magnitude. So resultant magnitude F is just equals to square root Fx square plus Fy square, which is equals to square root negative 4 square plus negative 37.8 square. And the final answer is 38.0 Newton. Okay, so remember to include the unit. Without unit, it's considered as wrong. Okay, without unit, it's considered as wrong. So next, I'm going to calculate the directions. Okay, determines the direction. So theta equals to tangent negative 1. So Fy over Fx, which is equals to tangent negative 1 negative 37.8 over negative 4. So angle is equals to 84.0 degree. Next step, remember you need to describe where is this 84 degree. Okay, because you can have 84 degree in every single quadrant. So what are you what are you going to do? You are going to describe the position. So you open a bracket, you look at your diagram. Okay, now the resultant vector F is located in the third quadrant. Third quadrant is below x-axis, so start from below. So third quadrant is located on the positive or negative side of the x-axis. Obviously, it's negative. So below negative x-axis. Okay, below negative x-axis. So that is the final answer. Okay, that is the final answer. So these questions, usually it will 5 to 7 marks in your final exam. So make sure you know how to start from the first step, which is move the vector from second quadrant to fourth quadrant, and then you resolve them into x and y component. After that, you calculate the resultant along x component, resultants along y component, and then you combine them, becomes a resultant magnitude of the vector. Okay, resultant force. And at last, you determine its direction. Okay, so now I give you 1 minute to write down the answer. Now, if you got the answer already, then you can try the next question. Next questions, I can give you a hint. You are given a diagram that shows the path traveled by the jet. So what are you going to do? You're going to generate an xy plane, and then you move the vector one by one into the xy plane. Let it come out from the origin. Let it start from origin, all the three vectors. Okay, all the three vectors. So remember, vectors can only living or coming out from a origin. Okay, from an object, from the center. So now I let you write down the answer. 1 minute for you to copy it down. And then if you are done, you may try question 6. Okay. So if there's anything that you don't understand, make sure to ask.
Madam,
Yep.
it's better ambil 2 or 1 decimal places.
Better 2.
Better 2.
Yeah, better 2.
Okay.
Okay, this one, because the answer scheme, they round it up to 1 decimal place, so I just give you 1. But if you calculate it by yourself, you better leave it at 2 decimal places. Okay. So now let's look at questions number 6. So question 6, a fighter jet starting from airbase A. It flies 300 km east. Okay, so this is the first path. And then 350 km at 30 degree west from north. So it's on the west side, and then it rotates 30 degree from the north. So this is your second path, okay, your S2 here. And then from a north, from S2, it then flies 150 km north. So your S3 to arrive at airbase B. How far? So how far mean it's asking for the resultant displacement. Okay, the resultant path traveled by the jet. So what are you going to do? So now we want to draw an XY plane first. So this is your X, and then this is your Y plane. Okay, XY plane. And then we are going to move the vector S1, S2, and S3 into our XY plane. So S1 is says going to east. So it's located along the X component. So this is your S1. which is equals to 300 km. Okay, and then S2 is towards this direction, and then 30 degrees from the y-axis. So this is your S2. So it's 350 km. And then S3 is 150 km. It's going up. So S3 is equals to 150 km. Now, how do I know the question is asking for resultant displacement? Because it says direct flight. So direct flight means it's a straight line in between your initial positions and your final position. So you are going to find the shortest distance between two positions. Therefore, we are going to calculate the resultant displacement. If the question is asking for the total path travel, then you are going to find the total distance. Remember what we learned yesterday, the difference between distance and displacement. So distance, you just add them up, 300 plus 350 km plus 150 km. If the question is asking for displacement, then you have to calculate resultant. How to calculate resultant? So by moving in, okay, by generating a Cartesian coordinate, then use it to find the resultant vector. Okay, so you're given three vector, S1, S2, S3. You put it in the Cartesian coordinates, then you resolve it into X and Y component. The main reasons why you need to resolve it, because now your S1, S2, S3, they are all pointing towards different direction. They are not lying on the same plane. Therefore, you need to resolve it. So if they are lying on the same plane, you don't have to resolve. You just add them up or you subtract them. All right, now again, I'm going to give you 2 minutes to complete this table. Okay, so let's try it out. So try to complete the table first. Okay, table is the most important things. If you got it correct, then you will get everything correct. If you got it wrong, then you don't even have to check the calculations after this. So table is the most important things in resolving vectors subtopic. So 2 minutes again for you to try. All right, now let's look at how to complete this table since you have two vectors that don't have an angle. So now you look at S1. S1 is lying on the X component, meaning that it doesn't have any Y component. So you don't even have to resolve the Y component. Straight away is equals to 0. Then X component, you just write down the value, okay? Because you don't need to resolve it. It means the resultant vectors along the X component for S1 is 300. So it's 300. Okay, you don't even have to resolve it because it's lying on the X component. Now let's look at S2. S2 is located in the second quadrant, which means it has a negative X component. and then a negative 350. Now, should I use sine or cos? The positions of the angle is beside y component. Therefore, for x component, we use sine. So sine 30 degree. Whereas for y component, now, second quadrant, you have positive y. So positive 350. Now you use cos 30 degree. S3 is lying on the y component, means that x3x is equals to 0. Whereas for the y component is 150 km. So that is how you resolve a vector when they are lying on the horizontal and the vertical components. Okay, means that you don't even have to resolve it. Straight away you got the answer. So Sx, okay, the resultant along x component is now equals to 125 km, and then a y component Sy is equals to 453.1 km. Okay, 453.1 km. So that is the table. Okay, you try to mark it yourself, see whether you got all of them correct. Okay, see whether you got all of it correct. It's very, very important, yeah, table. So now that you have this table, right, then you can then determine the final positions, okay, of a resultant vector. So x component, y component. So as usual, we are going to look at these two values. Okay, we're going to look at these two values to determine where is our resultant vector. So Sx is a positive value. So positive means it's lying on the, it's going to the right hand side. Okay, it's going to the right. So this is my Sx, which is equals to 125 km. Sy is also a positive value. So positive means it's going up, it's upwards. So I have a Sy going up. And this Sy is equals to 453.1 km. So if I combine these two vectors together, okay, I merge them to become a resultant vector, then this would be my resultant S. So my resultant vector is located in the first quadrant according to my table. That's why I keep telling you guys, table is very important. If you got it wrong, then the positions of your S would be wrong, and you won't even be able to calculate the resultant magnitude. So resultant S is equals to Sx squared plus Sy squared. It depends. It relies on the tables, okay? It depends on the values that you obtain from the table. So which is equals to square root 125 square plus 453.1 square. So the final answer is now equals to 470 km. Okay, 470 km. So determines the direction. So again, I'm going to use theta. Theta equals to tangent -1 modulus, and then a 453.1 over 125, and which is then equals to 74.6 degree. So according to my vector diagram above, okay, the diagram above, I have S located in the first quadrant. So first quadrant is above x-axis, and above which side of the x-axis? Above positive side. So above positive x-axis. So that is how you resolve it. Okay, that is how you resolve it. So same rules, I give you 1 minute to write it down. Okay, to write down this solution. And then we are going to proceed to the last questions. Okay, the last questions for today's section. So if you're done, then you may have a look first. And look at the words in bold. The change in velocity. So what does it mean? Okay, next questions, you are not going to calculate resultant anymore. You are going to find the change in velocity. So you try to think first. How are you going to solve it? Okay, how are you going to solve it? So you complete question 6. If you have any questions, make sure to ask. Okay, if no, you try question 7. All right. So far okay. Am I going too fast? Adakah ia terlalu cepat bagi anda?
Okay, madam.
No, madam.
Okay, good. All right. So I hope you can follow the speed. Okay, if you're having issues to follow the pace, then make sure to tell me. Okay, if I'm going too fast, make sure to remind me. So now let's look at the question 7. A gas molecule hits the wall of a container with a velocity of 200 meter per second. So U is equals to 200 meter per second at an angle 60 degree to the wall, and it reflected with the same speed in a direction as shown in figure. So this is also equals to 200 meter per second. So it says 60 degree to the wall. So it means 60 degrees here. All right. So from x-axis is actually equals to just 30 degree. So it's given in a diagram. So this question is being very, very nice to you because it gives you the angles, it gives you the diagram. Otherwise, you have to try to understand what does it mean by 60 degree to the wall. So what is the magnitude of a change in velocity? So change is no longer a resultant vector. Okay, it's asking for v minus u of the ball. Now let's start from a Cartesian coordinate. Whenever you have a questions that involve a vector, it would be a good idea to draw a Cartesian coordinate first, rather than just looking at the original diagram. So let us begin with the xy plane. So x and y. Now I have a u entering the wall. Okay, hit things on the wall. So I let it come out from the other side. Okay, so my u should be in the third quadrant. So u equals to 200 ms negative 1. And then angle is 30 degree beside x component. V, okay, now V is fine because V is coming out from the wall, is coming out from the origin. So I have a V coming out. So this is V equals to 200 meter per second. So again, it's 30 degree from the x component. All right, so once you have the diagram, the Cartesian coordinate diagram, then next part will become very simple. Why? Because you just have to resolve them and put it into the table. So you resolve x and y component, okay, resolve u into x and y, resolve v into x and y. But remember, your last step is no longer the resultant vector. You don't calculate the total. You calculate the difference between v and u. You use v minus u. So let's resolve it first. U is very simple, x component, now third quadrant, so negative. Negative 200 cos 30 degree, and then y component, since it's in the third quadrant also negative y, so negative 200 sine 30 degree. So when it comes to v, so what are you going to do in a v? For v, so v is in the fourth quadrant. Fourth quadrant, you have positive x component, so positive 200 cos 30 degree. And then for the y component, now y component is still going down. So what are you going to do? You're going to have a negative, okay, negative 200 sine 30 degree. Okay, now let's proceed to the next step. Next step, you don't add them up. You subtract it. You use v minus u. Okay, you don't use u plus v anymore because question is asking for the changes. So if question asking for resultant or it says total, then you just use addition. You add them up. Okay. So if the question is asking for changes, then you use subtraction. Okay, subtraction, or you say minus. So final minus initial. So these are the keywords that you have to check in the questions. Okay, see whether the question asking for resultant or asking for the changes. So now this question is asking for changes. So you're going to use final minus initial. So final in our case is v. So v represent final velocity. U is a symbol for initial velocity. So final minus initial. For x component, what do we have? We have 200 cos 30 degree minus negative 200 cos 30 degree. Okay, so what does it mean? It means you're going to add them up. So if you add them up, you're going to get a value which is equals to 346.4, if I'm not mistaken. Yes. So meter per second. Okay, so your Vx is now equals to 346.4 meter per second. So whereas for the y component, now you have negative 200 sine 30 degree minus a negative value. So minus a negative value, remember what is going to happen? So it will become a plus sign again. So eventually your Vy would be equals to 0 ms negative 1. Okay, because negative 200 sine 30 degree plus 200 sine 30 degree, it is equals to 0. So this is how you solve question 7. Okay, rather than you add them up, now you use final minus initial. Okay, because you're looking for changes. So the resultant vector, so again, we have a x and y plane. Next, we are going to draw it. So based on the answers given, I have only Vx that is a non-zero value. Vy is equals to 0. Means that my final answer, my resultant vector doesn't have any y component. It's lying on the x component. So therefore, this is my V. Okay, V equals to Vx equals to 346.4 meter per second. Okay, the reason why I know V resultant is equals to Vx, the final vector is equals to Vx, it is because my Vy is equals to 0. Okay, so if Vy is a non-zero value but Vx is a 0 value, Vx is equals to 0, that means your vector is lying on the y component. Alright, kalau x kosong, y tak kosong, bermaksud kamu punya vector jatuh pada paksi y. So that is how we determine the positions, the directions of a vector. So once you have a diagram, when you have a table, you are done with the table, then you can proceed to calculate the resultant. So now you can calculate the resultant. Why? Because you want to add Vx and Vy together. Okay, now you want to x Vx and Vy, therefore we can call it resultant. So V total, V resultant is equals to square root Vx square plus Vy square. But now your Vy is equals to 0. Straight away, it is equals to Vx, which is equals to 346.4 meter per second. Okay, that is because Vy equals to 0. So I don't even have to do the calculations. And the result in the directions, now direction based on the diagram is just going to the right. So you just say to the right. Okay, to the right. So done, that is question 7. So today we have tried 3 different types of questions. Where questions 5, it shows you what to do if you have a vectors entering an origin. And then question 6, we have a questions that shows a path traveled by an object. You yourself have to shift the vector one by one into a Cartesian coordinate. And then question 7, we look at what happens when we have a changes in a vector. We want to find the changes in a vector between initial and final. So we have done with 3 different types of questions. So now any question? Yeah.
Kalau macam contoh direction ke atas,
Yeah.
kita kata to the upward lah.
Upwards saja sudah cukup.
Upward saja. Okay.
Yeah. Okay, so kalau going up, then upwards, going down, downwards. And then along the horizontal component, you can say to the right or to the left. To east, to west, to north, to south also can. Okay, so there are several ways that can be used to describe the directions, and I have already shown you in the lecture yesterday. So all those terms can be used to describe a direction. Right, so any other questions? Any other questions? So if no, that's all for today. So yeah, so we are done with today's tutorial. So you have another 20 minutes break before you proceed to your next class. So you may leave the class now.
Okay, thank you, madam.
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 Madam.
Thank you, madam.